Ever been frustrated when your pipelines goes down right before a deadline? Or worried about your CI/CD provider changing their pricing or terms overnight? There's a new project that aims to solve this for good. This is Dcanary, the world's first fully decentralized CI/CD pipeline that runs entirely on the Internet Computer Protocol. Think about the core problems with traditional CI/CD. You have a single point of failure. You have vendor lock-in. And fundamentally, you have to trust your provider not to tamper with your build process. Dcanary flips this model on its head. Because it runs on a blockchain, your pipelines are unstoppable with no single point of failure. They are transparent, with every build being verifiable on-chain. And they're cryptographically secure. You don't have to trust the provider, you can trust the code and the consensus mechanism. This is a powerful idea. So, let's see how we can actually use it. Alright, let's get our hands dirty. The primary way to interact with the Dcanary is through its command line interface. First, let's paste the install command to get the CLI set up on our machine. With the installation complete, we can then check the version to confirm everything is working as expected. Perfect. Now, to get acquainted with the tool, a great first step is to use the help flag. This is your best friend for exploring what's possible. Let's run Dcanary help to view more commands and see the full list of options available to us. As you can see, we have commands for initializing a project, configuring pipelines, managing instructions, and more. This is the toolkit we'll be using to drive our entire decentralized CI/CD process. Okay, with the CLI ready, let's integrate a real project. The command for this is Dcanary init. The command kicks off an interactive process. First, it analyzes the directory and then asks for a project aimed to uniquely identify our pipeline on-chain. We'll call it MyApp. Next, it intelligently asks for the project type. This is powerful because it allows Dcanary to suggest sensible defaults. We'll select Rust Canister. Notice it then pre-fills the build and test commands, which we can accept. For the deployment target, we'll choose our local replica for development. And here is the most critical part. It asks for the decentralized build strategy. We're choosing the recommended consensus model. This is the very core of Dcanary's promise. It means multiple, independent nodes must build our code and agree on the result before it can be verified. This is how we achieve trustless builds. And just like that, it's done. Dcanary has generated the necessary configuration files and successfully initialized our project. It even gives us a handy list of next steps, like analyzing the new configuration, running a local build, and integrating with a Git provider. The foundation is now laid. But what does this on-chain configuration and orchestration actually look like in code? For that, we need to dive into the canisters themselves. The real power of Dcanary lies in its on-chain architecture. It's a set of canisters working together like a decentralized microservices application. Let's take a look at the core components. It all starts here with the webhook canister. This is the front door to the system. When you push code to GitHub, a webhook event is sent here. This canister's job is to catch that trigger, manage repository configurations, and queue up the initial build request. It's the on-chain entry point that connects the Web2 world of Git to the Web3 world of the Internet Computer. Once a build is triggered, the verification canister takes over. This is the brain of the entire operation. As you can see from the extensive type definitions for pipelines, stages, and results, this canister is all about orchestration. It's responsible for fetching the correct pipeline configuration, dispatching jobs to multiple executors, and most importantly, running the consensus algorithm to verify that all the build results match. It's the central coordinator, ensuring the integrity of the entire process. After a pipeline is successfully built and verified, the deployment canister handles the final mile. This canister's code is focused on the mechanics of deploying to the Internet Computer. It defines the different network targets like local, testnet, or IKE, as well as the deployment strategies like install or upgrade. It manages canister IDs, WASM modules, and the cycles needed to get your application live. And finally, underpinning much of this is the build instructions canister. This is the system's immutable rulebook. Its sole job is to securely store the actual commands for each stage of your pipeline, and security is paramount. If we look at the validate input function, you can see an extensive list of dangerous patterns. It actively blocks RM, RF, sudo, curl pipes. This ensures that no malicious commands can ever be injected into the build process. By separating concerns across these specialized, secure canisters, Dcanary provides a robust and transparent foundation for the future of decentralized CI/CD.